Hey everyone, welcome. We're going to throw through a couple of interesting scenarios today. We're going to spend some time talking about, how you can actually get to least privilege in an AWS environment, but not actually modifying every single policy of every single identity that you have. And so we'll spend some time talking about why this problem exists and how to actually achieve it using things like SCPs and other kind of centralized controls that Amazon has, and how you can make that a great experience for your team building in cloud, whether you have one team building or 50 teams building in cloud. We're also going to do a little bit of a demo of show how some of this stuff can look, depending on if you're using a product to do it or you're doing it yourself. As we do this. So we'll get started, and there's lots of time for Q&A, so feel free to put questions in the chat and we'll answer those at the end of the session. Thanks. So first, one of the things that we did at Sunrise Security when we started embarking on this kind of vision of, how to get things to least privilege without actually involving every single team to actually update every single permission of every workload they'd ever created. We started to look at a couple things around, what identities have sensitive permissions and which ones use them and things of that nature. And there were some great statistics that came out of this. One was a lot of the identities in cloud were granted at least one sensitive permission. And when we define sensitive permission, these aren't just like, read data out of a database. These are things like, you can change the network config, you can poke holes in the infrastructure, you can create pre-signed URLs that give direct access to data outside of the environment, you can terminate the account, you can do kind of really nasty things that would certainly change your risk posture of the cloud. And when we looked across the board, pretty much 50%, 51% of the identities had been granted at least one of those sensitive permissions, which would allow you to like privilege escalate or create a problem from an outside exposure perspective. But when we actually looked at what identities out of half the identities in the cloud that use them, this was the super telling thing. Only 8% of those identities had used them in the last 90 days. And so when you look at that statistic, I think it just confirms what we already know, which is most of the identities in the cloud are over permissioned with way too many permissions. And so you need to be able to fix this some way. And so you start to look at it and say, okay, well, we need to put least privilege on everything, and we need to update all these policies. There's another couple things that we started to look at from that, though, which was of all of the identities in the cloud, which ones are not used at all? So forget about just having access to a sensitive permission and using it, but no activity, absolutely none. And we kind of used a window for people that had been in cloud for more than 5 years. So they had built some amount of history, right? They had workloads that had been there and then gone away. They had built projects, that project got shelved. They had one project that was super successful and it had gone through, version 1, version 2, version 3. But after some period of time, what happened was a huge percentage of the identities in cloud were what we call zombies. They basically hadn't had any activity at all in like 90 days. And it was like 61% of the identities in these very large environments. You're talking about, systems with 250,000 to 500,000 identities, 61% of them completely unused. But the most telling kind of statistic across the whole thing when we did it was this last one, which is of those zombied identities, the things in the cloud that were sitting there, the separation between humans and machines became very clear. And only 7% of the zombies, so the 61% that weren't used, the 7% of those were human identities. The rest of them were machine identities or left behind identities after the machine was not used anymore, or whatever it was, they were sitting in the cloud. And this is really interesting because it really shows that the identity governance teams, when dealing with people, whether it's cloud or SaaS properties or your internal systems, probably have a pretty decent kind of lever, mover, joiner process. Somebody leaves the company, they know how to take their permissions away. Somebody moves from project A to project B, they have a pretty decent way to make sure that their permissions go in the right spot and the old ones get removed. But when it comes to machine identities, when you go to version 1 of the product to version 2 of the product, and you don't use that old identity that was part of version 1, it just sort of hangs out in the cloud forever. And you end up with this very large portion of unused identities. And this is an example of, a real customer with some real numbers in here to kind of give you an idea. They had 26,000 identities that are completely unused in this environment. They had, 25 or 20,000 of them that had excessive permissions. They had one of those sensitive permissions that they don't use. And, if you look at AWS, it's just what this kind of presentation is about. They actually had 152 AWS services that aren't used at all that everyone was permissioned to. And you say, well, how does this happen? Well, clearly the DevOps teams are running fast. They're not being asked to make sure everything is perfect. They're trying to get their release out, right? And they need to get their features out and all those things. And as they would do that, and we try to shift left and we say, oh, we'll lint your policies, make sure you don't have Lambda star in it. But we're probably not building perfect policies at that stage. So the stuff slips into production. But the cloud ops team that wants to take that and make it better doesn't really have a way to put centralized controls on top of these things, because if they did, they could break running workloads. And so you get this kind of weird tension where the dev teams are trying to ship more code faster to get to better product fit and market fit and all those types of things. And then you've got the cloud SecOps team that wants to kind of lock down some of these sensitive permissions, but are really worried about breaking something if they do it. And so we looked at a very different approach at this. We basically looked at, today, what happens is that when one of these workloads gets deployed with an identity, DevOps team releases it, we monitor it for a period of time with the current tools, and we build a least privilege policy for it. At that point in time, we give that policy back to that team. They encode that in their Terraform or whatever they're doing to roll those policies out. They probably check it in, dev and UAT to make sure it doesn't break anything, and then they ship it to production. And probably by the time they shipped it to production, the workload has changed and they need a different set of policies on it. And you rinse and repeat that over and over. And we had this pretty successful company in the financial space that was able to do 2,000 of these identities in a 10-month period. And they got them all the least privilege doing this process. But when you look at that 10-month period, you're like, they probably created more than 2,000 identities in that 10-month period. And so you just never get to be done doing it that way. And so we took a different approach. We said, look, what if we could actually do this centrally? What if instead of looking at all 14,000 permissions in AWS, we only looked at the most sensitive ones? There's about 1,000 of them, give or take. And we reviewed all the policies. Instead of actually looking and fixing every policy, we write one global policy and we deploy it centrally and we control it centrally. And by doing this, we ended up with a scenario where we got very, very good control centrally of the most sensitive things, but allowed almost, go back to your 92% of the things that have sensitive access never use it. The 92% is completely unaffected. Nothing changed. And you only need to worry about the 8%. And we'll talk about how we deal with those in a minute. But you get to a point where you can remove all of those sensitive permissions from all of the identities that don't use them. Another thing we were able to do was say, we can actually remove all of these unused identities. And people, again, I've been at this now for 4 or 5 years in the CIM market, the cloud infrastructure entitlements management market. It's super easy to delete an identity out of the cloud. You would think anyone can do this. But when you really get down to it, it actually is a hard thing to do. You'll see an identity that hasn't been used in 180 days, and you'll say, okay, let's go delete that. But we better check with the team. And then you find out the team doesn't even know who put it there, or it's configured in a way where it has an access key in. And you're like, well, does that access key in any other system used in another piece of code? It has resource policies on resources that refer to the ARN of the resource in AWS. And you're like, I can't delete this. I can't put it back if we delete it. And so we found a way using a quarantine function to basically deny access to these zombies without deleting them. And so we can take the risk out, but leave them in place so that you can wake them back up later. Same thing with unused services. We can detect what's there, remove the ones that aren't used. It just removes a lot of these permissions that are latent and not used. When everybody was given star permissions, you can take those away. Same thing in regions. And so what happens is you end up with a scenario where if we read backwards in time, we can figure out what uses the sensitive permissions. We can build the right exemption list. So now the 8% of things that did use the sensitive permissions are still granted access to use them. We don't break anything. And tomorrow, when a new identity that's never used a sensitive permission bumps into one of these controls that are deployed centrally, we simply send them a message, or the team a message, or whoever the approver is, to say, hey, this was just denied. Do you want to approve it? You hit approve. We give the permission back immediately. You rerun that workload, that piece of Terraform, whatever that is, and all of a sudden you have access to it almost immediately. And because these centralized controls are deployed on top of the actual permissions that the workloads are deployed with, they may be deployed with star. You don't really have to be as scared of star anymore because the really sensitive permissions have been removed for it. And only on an actual usage of them do they end up getting approved. And so you leave that 92% that never use them in that unused state. So it gives you a great way to do this. You get a rapid start. You kind of read through the history. You understand which identities need access to sensitive permissions. You lock those down. And then on day 2, you actually can start doing what we call permissions on demand, where as each permission is needed, you apply it. And you would say, well, look, I can't have all my teams just applying okay and approvals to permissions every day. A separate set of statistics we did showed that in any given team, the number of these permissions on demand requests for these very sensitive permissions are actually quite low. On average, it was like 5 per month. And the reason for that is that when you create some sort of a production workload and you have a development and a staging and a production environment, you create the VPCs one time. You don't change them and delete them with every deploy. You create the security group rules around that particular namespace. You don't change them every workload. And so the number of times that you need to do these very sensitive things is actually much lower than you think it is. And of course, you'll have global roles like a deploy role or something like that needs them. But of course, that gets exempted in that first step because it does it all the time, and therefore is already in the list of exemptions. So anyway, that's how it works. We were going to kind of show an example of this, but this is something you can start to do fairly quickly even yourself. We always call them the no-go permissions, the ones that you should never allow, stop logging and things of those natures, certain types of creating pre-signed URLs, stuff that poke holes in the network. Those actually you can kind of put in a deny today in an SCP and block them from ever happening in your cloud at all, because no identity should be able to do those without somebody at the top level removing that restriction. But there's even ways, we've seen many companies even build other scenarios similar to this where they're mining the log data for these kind of denies and then sending the developer a note saying, hey, by the way, you're not allowed to do that. If you need access, do this approval process. So we're going to try to do a share. Now, this is the first time with this platform we're going to try this. So we're going to see how many security pop-ups we get. I'm going to share my screen. And I'm going to actually do this whole tab. Hopefully this is going to work. Window here. Hopefully everyone can see that. I have a couple of screens that I'm sharing here. So hopefully you see an AWS portal right now. And then we have over here, what we're going to use is a product to kind of show this and how this works. So the way that this actually works is that the SCPs get deployed at the top of your AWS organization. You may have multiple AWS organizations. You can hear here, I've got a demo organization here, which has huge numbers of accounts in it. And then I've got this Sunry PS organization here with a number of accounts in it. We're going to use this one as our example. But you can deploy controls kind of at the top, or you can actually look at an individual account. So I could go down to my dev at Chatmaster account here and see what it's like. Now, in this case, I've actually deployed protections in place. So I have blocked all of the sensitive permissions and I've quarantined all of the zombies so that they don't have access to anything anymore. But again, if you were to do this kind of back up here at the top of the tree, you could go and preview and we would say, hey, well, maybe in this area, I've got some guy here who hasn't been active for 3 months. If I want to quarantine them, I just hit quarantine. And again, that will block that identity. But if it ever wakes up, it would get a permissions on demand at that point. Same thing. I'm only actually using 28 services across this entire scenario. So again, we can disable the services that aren't used with one click and get those protected. This one's, of course, all protected. If I go to, this other environment, I have a whole bunch of identities with access to sensitive permissions, and I have a whole bunch of unused services in this scenario. And of course, I can see, what those unused services are. If I want to disable those very quickly, can hit disable, and that will actually go. And what it does is creates what call a pending change. So it's going to take a while. There's a lot of accounts in this particular one, but it will create a pending change where I can then deploy that as a piece of infrastructure as code, and it will block 100, or there's 24,000 changes there to only the 14 services that are used across these hundreds and hundreds and hundreds of accounts. Let's go back to Summary PS where we were doing our little demo. This one's already protected. We've deployed the infrastructure as code. So the SCPs are in place and all the blocks are in place. And we can see here that the EC2 service is in a protected mode. There's my chat master account. It has an exemption in it. So apparently this particular summary collector is allowed to do sensitive permissions in this account, but nothing else is. And so let's bunch over to the AWS console. I'm going to log in to the chat master account as an administrator. So you can see I'm logging in as the administrator access, full star permissions. I'm in here. And again, it wouldn't really matter who's doing this, but I'm just going to create a VPC because that's part of the EC2 service. And so come in here, I'll create my VPC and I will go and say, I'm going to do this to a project test A. And I would run this and I'm going to create a VPC and immediately I get denied. Now, you won't be able to see this because it's shared in a different window, but I'm going to get a Slack message almost immediately that says, hey, there was just this deny that happened. Do you want to approve this from happening? And I can actually show this back, I believe, in the UI as well. So I'm going to flip back over to the Sunry scenario and I'm going to go to request. Normally you would get this in Slack, but we're going to do it here in the UI. And so you can see this is pending, and you can see here this particular administrator basically tried to create a VPC. That's fine. I want to approve that. You click approve. You put a message in, approved, whatever. And go. And so that gets recorded in the system. Now, the reason it knows to send it to the right person in Slack or in Teams or in email or however you're doing this is that you create an approvers flow that says for any given area, who are the identities that are supposed to approve this. And so what's great about this is in development environment, you can use self-approval. And so the teams can approve their own things. But then when you go to prod, maybe you need cloud ops to approve it. Maybe you need a central architecture board to approve it, whatever it is. So you can have different levels of approvals depending on which part of the organization or which level of development they're at. But any approvals that are made in development, you now know the lists that need to be approved in prod when the thing goes to production. Because if a part of that workload needs access to a sensitive service and do sensitive permissions in it, again, that will be part of the development cycle as you go through it. So as opposed to trying to build perfect policies for everything on the way through, let's just figure out the ones that do sensitive services. Now that I'm approved though, again, if we go in here and look at this dev chat master, 2 identities now, there's my SSO role. I can come back in here, do the same thing I did before. I'm going to create a VPC, project test B, hit go, and now it works. So within, I would have gotten a message in Slack too, just say, hey, this has been approved. You can now go do this. And as soon as I do that, it's kind of a person identity doing in this case because I'm using my own identity. However, it works the same when this is being rolled out through automation, Terraform, whichever, because it's the team that's getting the actual approval. And so they'll see, oh, you just ran that Terraform thing in Slack. They get this message saying Terraform was just denied access to create the VPC. Do you want to allow it? They hit approve, they run the Terraform again, and then it works. And so it's really easy to get access in that scenario. So that's kind of the quick rundown of this. I'm going to stop sharing. We're going to open this up for some Q&A. I'm probably a little shorter than I needed to be today. We usually take a little longer to do these ones, but I think it kind of shows the whole point through and through. And so I'm going to move over to the chat here and see if there are any questions. Okay, so some in here about number of policies around OU. So I'll paraphrase this one a little bit. In AWS, when you're applying service control policies, there's a number of limits. And so one of those limits is the number of OUs that you can, the number of SCPs that you can attach to any given OU. And then, inside of those SCPs, there's a size limit to them. And so the question is really like, what's the minimum number of policies per OU you would apply? The minimum is actually going to be defined on your actual workloads themselves. So if you only use 3 services, maybe you only need 3 policies. They'll probably be in one SCP because you want to save space by doing that, but 3. But if you use 46 services, then you're going to have 46 policies there. We do a lot of work in our product to compress those and do some really interesting things using attribute-based access to make them smaller. But in your environment, if you're testing it even without the Sunry product as an example, there's some interesting things you can do to compress those and make sure that you get a minimum number of attachments at those space. You can also do it by nesting your tree deeper. If you only have 2 levels to the tree in AWS, you can actually kind of put a fake level in and get some more space up at the top if you need that. Hopefully that's helpful for that. Second question here, how do you test SCPs? Is there any way to simulate it without deploying in a separate test org? So SCPs are live as soon as you put them in. So you don't, there's really no testing of SCPs in terms of, oh, we're going to drop this SCP at the top and then see what happens. But there are 2 things you can do. One is if you want to know if, and I'll use the example of stop logging as an example. You shouldn't be running that anyway. But if you were running stop logging and you wanted to see if anything in your environment would ever get blocked if you put that SCP in place, you can mine through your CloudTrail to do this. And this is what all of the products, whether you're using IAM Access Analyzer, you're using the Sunry CIM product, whichever, or any other of these kind of KIM products, that's what they're doing to figure out how to build the best policies for your workloads. They're basically mining through that previous CloudTrail data before putting an SCP in. You can test it the same way. You can look back in time and make sure that's there. You have to be careful of a couple things in AWS. Clearly, the action needs to be monitored by AWS. Not all of them are. So again, if you're calling certain actions on an API, it may not be monitored, and you need to make sure that's the case before you put it in SCP. The other thing that you can do to test these things is actually to test them in, as an example, a development versus a production org. So you put it in a similar environment, but in a non-critical spot, test it there to make sure you don't run any blocks before you put it in the production side. But SCPs are live when you don't get to, you don't actually get to put them in test mode, so to speak. One of the ways we solve that in the Sunry product is we put it in kind of monitor mode first, so you get to see all of the data and what it's going to do before you actually press the buttons and deploy the SCPs. A couple more questions coming in here. If we block something that was needed, what sort of delay is there in re-enabling the disabled policy? It's speed of cloud, so it's in the seconds, right? So the question said, is it minutes or seconds? It is absolutely in seconds. And the reason that works is that we put monitors in place to hook when, and again, if you're AWS, you know about Event Bridge and things like that. So we're using Event Bridge to know that as soon as something bumps into that SCP, we know about it. From there, we can send that message off to, chat ops, could be Teams, could be Slack, could be email. Those systems are fairly quick at those messages. So by the time AWS sees it, hits it in there, you're talking a couple of seconds. The one I just did here is an example. I hit go, and within a second, my pocket was buzzing. I could feel the Slack message. So I knew that had gone through. When I hit approve, that's also round trip a couple of seconds. So it's about, I always tell people 20 seconds is a comfortable number. It can always happen cycle to cycle. Your biggest delay is the person that has to hit the approve button. That's the one where, if no one's around to do it, it's on the approval list. What we do is we generally have a second line approval that happens. So after 15 minutes, we jump it to the next one. Last one in this list. So we temporarily need to lift the SCP restrictions for some major migration. How can we apply a time limit exception to the SCP that will not stay indefinitely? So this is actually, I'll give 2 answers to this question. So the AWS policy language actually allows you to place time-based restrictions in that. And the way the conditions work, you can apply them in a positive state or a negative state. And so if you do that, you can actually put in the SCPs themselves a zone where they will not apply based on time. So you could absolutely put a temporary exception in your actual SCPs themselves. That's probably overkill. You got to know how to use condition language. You got to use some very specific AWS stuff. You have to redeploy the SCP anyway. So it becomes a complicated thing to do all those steps. The easier way to do that is just to roll the SCP out and then roll it back in. And so in the case of if you're doing this yourself, not with something like the Sunry product, you can just detach the SCPs you've created from those points in the account tree and leave them detached. When the deploy window, the migration window is over, reattach them. Super simple. In the case of Sunry, there's a big button at the top that says roll out all my changes. It rolls them out, puts them into a pending state, do your migration, whatever you need to do, hit redeploy, and it just rolls them all back in. So even if whether you're doing it, manually yourself, or you're actually doing it as part of the kind of a product like Sunry that's doing this in an automated way for you. There's ways to do it. You can actually write it right in the SCPs. I don't think I would do that. It would be overkill to do it that way. I think that's all the questions. That's all I see here in the chat. Again, thanks for some of those questions as we come through. Great talking to everyone today. Hopefully this session was useful. If you're interested in something like trying out the Sunry Cloud Permissions Firewall, which does a lot of this work in an automated fashion, we have a great spot on our website. You can do a 14-day free trial, all of those things. Anyway, thank you very much. Bye.